Hi everyone, so let's do this question. Today's daily Lead Code challenge question was hard, so I chose this question instead of daily Lead Code challenge question because this is just a medium level. Okay, so I have set a timer. Now let's read this question. Before reading question, I always like to copy the input because because yeah, it is easy because in the this is just purpose. If I just look at this data, then it is easier for me to understand. Okay, so we are given two zero indexed integer arrays, servers, and tasks of length n and m respectively. Okay, so this is length n and this is m. Okay, and servers I is the weight of the ith server, and tasks j is the time needed to process jth task in seconds. Okay, so servers I is the weight of the ith server. Weight, what does weight mean? Weight of the ith server, and task j is the time needed to process the jth task in seconds. What does server and task mean? What does weight of the server mean? I don't know. So let's see. Tasks are assigned to the servers using a task queue. Initially, all servers are free and the queue is empty. Okay. And at second j, the jth task is inserted into the queue. At second j, okay, the j task is inserted into the queue, starting with the 0th task being inserted at second 0. I just feel like I'm not sharp enough. My mind is not sharp enough right now to just understand this at once. But still, I'll try. Okay, let's see if I understand this question at once. So at second j, the jth task is inserted into the queue, starting with the 0th task. I'll need to move. I'll move to somewhere so that I can rest my back. Okay, let's sit here and do, because here I have back support. Oops. Okay, let's do it now. So at second j, the jth task. At second j, the jth task is inserted into the queue. Second j, the jth task is inserted into the queue. At second j, the jth task is inserted. So the queue is empty in the beginning, and second j jth task is inserted. Okay, so it's inserted into the queue jth second. So this first second task 1 is inserted, and then second task 2 is inserted, and third second task 3 is inserted. Does this mean that? I think so, right? Starting with the 0th task being inserted at second 0. As long as there are free servers and the queue is not empty, the task in front of the queue will be assigned to a free server with the smallest weight, and in case of the tie, it is assigned to a free server with the smallest index. Okay, got it. If there are no free servers and the queue is not empty, we wait until a server becomes free and immediately assign the next task. If there are no free servers and the queue is not empty, if there are no free servers and the queue is not empty, we wait until a server becomes free and immediately assign the next task. Okay. If multiple servers become free at the same time, then multiple tasks from the queue will be assigned in order of insertion following the weight and index priorities above. A server that is assigned task j at second t will be free again at second t plus task j. Build an array answer of length m, where answer j is the index of the server the jth task will be assigned to. Return the array answer. Okay. So for this one, at second 0, at 0th second, what will happen? At 0th second, task 0 is added and processed, right, using solver 2 until second 1. Because this is the time needed to process the jth task in seconds. So this first one will be inserted. So this is 0, 1, 2, 3, 4 and 5. Okay, so at so for 0 task at second 0, so I mean these are all the seconds, and this is how much time needed. Okay, so at 0 second, task 0 is added and processed using solver 2 until second 1, and then at second 1, I mean it will be solver 2 is processed because 2 has the smallest weight, right? So 2 will be processed, and then so solver 2 will process 1, and then at second 1 the solver 2 becomes free. So task 1 is added and processed until using the solver 2. Okay, so now this task 1, solver 2, task 1, and then solver 2 becomes free. After 1 second, solver 2 becomes free, so solver 2 will solve now another task 2. Right, and task 2, so task 2 it takes 2 seconds. Since it takes 2 seconds, so it will be for solver 2 task 2. I'm sorry, I'm very distracted. I need to do something. Sorry, just a second. I'm just distracted because I have to do something. Okay, so solver 2 task 2. Solver 2 task 2 is added and processed using solver 0 until second 5. at second 2 so at second 0 task 0 is added and processed using solver 2 until second 1, right? 0 is added, okay, so this is added and then process until solver 2 until the second 1, and at second 1 solver 2 becomes free. So since at second 1 solver 2 becomes free, so second 1 the solver 2 becomes, I will only do this until it's 9 minutes. I'm not going to do it anymore because I'm already late. So at second 2 task 2 is added and processed using solver 0 until second 5. This is too much, I'm too distracted. So at second 2 normally I get distracted when I do not understand things. When I am fully engaged, then I don't become distracted, but if I'm not getting things, then other thoughts, like I start getting intrusive thoughts. So that's what's happening right now, because I'm not getting into this problem. I have not engaged in this problem. I have not, that problem has not sinked in inside me. Otherwise I would have been very, very focused. But okay, so let's try to understand then. So yeah, at second 0 task 0 is added and processed using solver 2 until second 1. At second 0 task 0 is added and processed at second 1, second 2, 3, 4, 5. So what happens at second 0? This task is and processed using solver 2. What happens at second 1? Solver 2 becomes free. Task 1 is added and processed until solver 2 using solver 2 until second 3. Okay, what happens at second 2? Task 2 is added and processed using solver 0 until second 5. Okay, and what happens at second 3? Solver 2 becomes free. Task 3 is added and processed using solver 2 until second 5. But solver 2 was free already here, right? Processed using solver 2 until second 3. Oh, because it takes 2 seconds, right, for this one, so that is why. Oh, got it. I get it now. I get it now. Yeah, so I was almost giving up this problem, but I get it now. So what this problem is trying to say is every second, okay, so actually I can just sort this, right? 3 3. So first of all I need to use solver 2 and then solver 3. So this is the order, okay, this is the order of how I can use the solver, okay. And the thing is so this means this first task takes 1 seconds, this takes 2 seconds, this takes 3 seconds, this takes 2 seconds, this takes 1 second, and this takes 2 seconds, okay. And so in the beginning at the second 0 I can just skip this task, right, this first task. So first task solver 2 will be assigned task 1, okay. And then since it is just task 1 task 1 and it takes just 1 second, so solver 2 will be free in second in another second only, second 1 only. So this is second 0, right? And then in the second one, what are the free solvers? These are the free solvers again. So 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 now let's look at the task 2. Task 2 will be assigned to which solver? So task 2, it takes 2 seconds. 2 seconds will be assigned to solver 2 only, because this is the top, right? Solver 2. So now solver 2 will be free after, will be free in how many seconds? So this is second 1, so 1 plus 2 is third second, right? Because we got this in third second. Okay, now second 2. So what is the free solver? Just 3 and 3 only at this point, because solver 2 will be free only in third second. So here now task 3, it takes 3 seconds, right? So it will be assigned to solver 3, because it will be assigned to solver 3 because this is the order of the solver. Order means the solver of whichever weight is the least, that is the first solver that we should use, and then the other. So anyway, like this order I can just build this order. Okay, so this is the order, suppose. Then task 3 assigned to solver 3, and then and this now solver 3 will be free in how many seconds? Will be free in because it takes 3 seconds and I got this in 2, so it will be free in 5th second. Now second 4, task 4, right? So task 4, how much time it takes? 0, 1, 2, 1, 2, 3, 4. Task 4 takes 2 seconds. So it will be assigned to, so what are the solvers that are free here? At second 4, what are the solvers that are free? Just, so this will be free in second 1, and solver 2 will be free in third second. Oh, actually this is third second, isn't it? This is 1. So since in the third second this will also be free, solver 2 will also be free. So these are the solvers that will be free here. Yeah, so since this will also be free, so task 4 it will be assigned to solver 2, because so in the beginning these are the free solvers, right? 2, 3, 3. So 2, and then it will be free. So 2, 3, 3, 2, and 3, 3. So it takes 3, and then here 2 and 3 will be, so it should take 2, isn't it? At second 3, yeah, solver 2 becomes 3, and task 3 is added and processed solver 2 using second 5. Yeah, that's what I'm saying. So second 3, and then it takes 2 seconds. So this solver 2 will be free in which second? 5th second. Okay, now second 4. For second 4, what are the solvers that are free? Just 3 only, right? Because 2 is taken. So yeah, now task 5. Task 5 just takes 1 second. It will be assigned to solver 3, and so solver 3 will be free in 5th second only, because this we got at second 4, and it takes us 1 second. So in the 5th second, again so many solvers will be free, right? Because this will also be free here, solver 3 will also be free, 2, 3, 3, everything will be free. So all solvers are free here, and then task 5 is added and processed using solver 2 here. Yeah, so this is added again into 2 here. So that is why the output is So that is why the output is solver 2, solver 2. And yeah, so what is the output? Like answer of length m, where answer I is the index of the solver, the jth, right? Yeah, so that is where the answer is. So the solver 2, solver 2, solver 3, solver 2, and solver 3, this is the answer. Okay, yeah, so I just need to take 5 seconds, and then task 6 will be assigned to solver 3, solver 2. Okay, so this is the thing, it will be assigned to solver 2, and we should just the answer will be just the solver, you know. So the first task we assigned solver 2, for the second task we also assigned solver 2, for the third task we assigned solver 3, and the fourth task we assign solver 2, and then we assign solver 3. So 1 2 3 4 5, right? Yeah, and we should not send the solver name, but we should send the solver index. So where was solver G2? So it was at 0 1 2, right? So that is why the answer will be each index 2 2, and we need to find out what is the index of this solver 3. We need to find out, you know, what is the index of the solver 3 that was used, because there are two solver 3, right? There are two threes, so we need to find out what is the exact index of that one. Yeah, yeah, so I think there are two index of 3, and then 2 and index of 3. So answer will be indexes of, or we can say indexes of. Okay, so I think there are two things for coding that I need to figure out. So first of all, how will I sort this array? First of all, I need to sort the solvers, you know, in order, and also preserve their, yeah, I need to sort the solvers in order, so that I know, you know, exactly which one to use whenever something is free. And the another thing I need to think about, how will I know at any given second what will be free? You know, that is a thing. So because at any given second we need to know which servers are free, right? So I think what we can do is what we can do is we can just create a hash map. So for this is one thing, and this is second thing. Okay, so for the second thing, solution for second 3, solution for 2 is, I think we can just build a hash map for something, and then in the beginning everything is free, right? So in the 0th second everything is free, so all the solvers are free. So solvers 0 1 2, 0th second, in 0th second every solvers are free, right? 0 1 2, all the solvers are free. And then for now I'll just name the solver, right? Okay, solver 2, solver 3, and solver 3, all the solvers are free at this second, right? And then at 0th second only I will know, you know, solver 2 will be free at what second. So So suppose here I will know that server 3 will be free in 5th second, right? So I think what I can do is I can say that okay, this is a 5th second, so in the 5th second server 2 will be free, server 3 will be free in 5th second. And whenever I reach 5th second, then I can just look at this hash map and see what are the servers that are free. You know, so this one can just be, this one can, so first of all we can just say the remaining servers, unused servers, okay, unused. So in the beginning we can just calculate unused servers is equal to create an array for unused servers, okay, create a set for unused servers. And then we also need to create a hash map for servers to be freed, okay, here. So at every second, when we use any server, we can just remove from this unused server, and then yeah. So if we have this so at every second we can use these unused servers and servers to be freed data to get list of our servers, right? So because unused servers, so at any seconds, so suppose at second 2 unused server is server 3, okay. Suppose at second 2, then unused servers is say server 3, all the server are used. And then in the hash map, I do not have anything for second 2, okay. Then it means that this is the only the server that is remaining. Or suppose at second 5 unused server is still server 3, then also total servers I can use will be unused server plus servers to be freed at second 5, you know. Yeah, so once I know this thing, I can just know, okay, once I have all the list of the servers, then I can know, then I can just directly know which one to use at that point, okay. So this is how my solution, which servers are free, right, or free, or what servers I can use. So this is a solution for 2, my problem second number 2. But how do I know, you know, so how do I know, like suppose if I have all the servers, okay, then how do I know which server to use? How do I know which server to use? So I think that we need to give weight for all the servers in the beginning only, right? So if there are server 332, then we need to give weight to the server at the beginning only, because 332. So at index, so I think so I think all the server name, it should be attached with something, some weight or something, 0 1 2, yeah, 0 1 2, and then weight, yeah. Yeah, so because like suppose, okay, this is the unused servers, right? So suppose in this case, okay, this is the list of unused servers. So server 3 comma server 3 comma server 2, okay. Suppose at any given point, suppose if free servers are this one, then how will I know which one to use? I think I need a hash map or something to attach, you know, that okay, 0 will be 1 will be this one, 2 will be this one, or something like that. Yeah. I need something like this, you know. So 2, if I know that this is the first priority and the 1, yeah, I need to have something like this. Maybe first of all I can just order it as, like, I can just say 0, 1 and 2. No, so how will I know which server is the biggest priority? Suppose this server 3, server 3, server 2. Okay, so this is our index 0 and this is at index 1 and this is at index 2, right? So if I know that, okay, these are the free servers, then how will I know which server to use? Just by looking at this. Because every time I do not want to go through all the array and then pick out the biggest one, you know. I just want to know just by looking at it directly. I cannot even sort it, isn't it? If I sort it, then what will happen? If I sort it, then it will be like something like this, 3 3 2, right? Then if I sort it, then it will be 2 3 3. Is there a way of finding it without sorting? So my question is, if we are given, if we know that for how to know which server to pick, that is the question, right? If we have all the list of the free servers, then how to know which server to pick? Because there can be so many servers at once that will be free. So sometimes this can be free after this, and sometimes this can be free after this, sometimes this can be free after this. At the same moment, so many servers can be freed up at the same time. So how will I know which server to use at the same time? Like, if 3 3 1 2 3 4 is, then I will have to sort it and then do that again and again and again. So instead of that, is there any way just to find? No, I don't think so, right? I think we have to sort every time, sort it and find that every time. There is no any map like that. Yeah. Okay, my time is over, so let's just look at the solution.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem from today's LeetCode contest, process tasks using server. In the one time do a task all through, maybe I'll have to assign to a case where in this part of the
Okay, so does it
time too. And the value of each task is basically the amount of time it's going to take a server to process it. So for example, if we assign this task 1 to a server, that means it's going to we obviously start at the point. So for example, in this two exact same smaller is which task we wait equals 3 that we now. Why it would be like this is basically for each task we would potentially have to iterate through the entire server's array to find the server available with a minimum wait and then assign it to
yeah, that's what I was saying. Like, we have to iterate through the whole server array, you know, free server array for every task, which is very bad. There is no any other way.
The server and then basically continue on and on and on. And if we ever got to a case where, let's say, none of the servers are available, but we know that a server is going to be available, let's say at time equals 6, but maybe our current time would be something like 2, then we would basically say, okay, we're waiting to assign a server. None of the servers are going to be available at time equals 6, so we're just going to take our current time, add 4 to it, and then say, okay, now let's get that first server that's available. So that's not going to take any extra time, right? We can just advance time arbitrarily as soon as we want to. But we still are going to have to iterate through the entire server's array. The actual time complexity can become something like m log n, where n is the size, can be solved more efficiently arbitrarily as soon as we want to. But we still are going to have to iterate through the entire server's array. But this can be solved more efficiently with a min heap. So the actual time complexity can become something like m log n, where n is the size of the server's array. I think I might have said it backwards earlier. I don't remember, but hopefully I didn't. So n is the size of the server's array, m is the size of tasks, and we can put all of these instead into a min heap and then make it more efficient like that. And that's the solution I'm going to be coding up and explaining to you today. I don't know if there's actually a more efficient way. Maybe there's like a really greedy solution that can actually be better than.
Yeah, min heap is the way, because in the min heap it will always be we don't have to go through the entire array, right? Because in min heap if I enter some number, then it will always give me the minimum number, so you don't have to sort every number all the time.
Than this, I don't know yet, because the problem hasn't become public yet. It's only a part of the contest, so maybe somebody will have a more efficient solution. But for now, this one did pass the contest for me, so this is what I'm going to show you. It might look a little complicated, so let me servers that were given an output array, basically assigning to, so that we have that heap. So the available, the take available, the being assigned after it becomes free. For example, you'd be free ready at 2, and we want to advance time all the way to 4. So initially, we're going to take all the servers and add them to the min heap of available servers. So one server has a weight of 2, and that server is at index 2. The other server has a weight 3 at index 0, and there's another server with a weight 3 at index 1. So we're going to start at the first task, and our time initially starts at t equals 0. So we're going to look for a server for this first task to be assigned to. So what we're going to do is find the minimum from our min heap of available. The smallest weight is 2, so we're going to pop that server, add it to the unavailable servers, so 2, 2. But don't forget, we need to add the time that it's going to become free. So this task has a time duration of 1, so we're going to take our, and task was assigned to a server at index 2, so that's what we're going to put in the result. So now our next again, because our time on 2 is back available back here. So this time, this task takes 2 seconds to complete, and our current time is t equals 1, so that means this server is going to become available at t. Finish the rest of the is going to be increment. Pop the one with a smaller index, so we're going to pop this one and then add it to our unavailable server. So it has a weight 3, index 0. And what time is it going to become free? Well, the current time is 2. This task takes 3 seconds to complete. 0. So that's basically what we're going to be doing. You can see so far our result is 220. You'll get the all the servers are available, and our time is 2.
I will learn about heap though. Yeah, I will learn about more about heap, because I did not think about heap. Okay, let's go. Bye bye. Thank you very much for watching.